In this video, I'm going to be talking about what is called hemostasis and the arrest of bleeding or the stopping of bleeding. Because again, if we keep losing blood, that's going to throw us out of whack and throw off homeostasis. And make sure you understand the difference between the terms. This is hemostasis, the stopping of bleeding. Also, I've tried to do this video 5 times, and every time I start, someone downstairs starts moving a table or drilling or something. So if you hear a loud noise in the background, I'm just going to work through it. So what we're going to do is go through the different steps of how the body attempts to stop bleeding. The first phase is going to be the vascular phase. And so when the cells of a blood vessel are damaged, what it will cause them to do, it will cause them to contract to some respect in what's called the vascular phase and called vascular spasm. So they will spasm, and again, if they spasm and constrict like that, then that's going to try to prevent blood loss. That will work for a while, but what will happen is if there continues to be some blood loss, the cells of the blood vessel will not be getting enough nutrients and it will not be able to continue that spasm. Spasm. So what's going to happen is as that spasm is occurring, chemicals are being sent out that are going to attract platelets. So we talked about this actually at the beginning of the semester. So with the damage, there's a chemical, it causes platelets to stick. So 1 platelet's going to stick, then 3 platelets are going to stick, 7 platelets are going to stick, and it's going to keep increasing the number of platelets that stick to form what is called a platelet plug. The question is, what type of feedback mechanism is this? Is it a negative feedback mechanism or a positive feedback mechanism? Is it bringing it back to set point or away from set point? In this case, it is a positive feedback mechanism because we're increasing the platelets that are sticking until we accomplish the goal, which would be to stop the bleeding. Okay. There is one more phase here. Those platelets are going to send out signals, and that is going to stimulate what is called the coagulation phase. So coagulation is the process of stopping bleeding and forming a clot. Now remember, when you learn blood types, we talked about the term clump. The clumping of blood cells is an immune response, okay, because of antibodies, because of not matching blood types. Coagulation is coagulation is the process of stopping bleeding and forming a clot. So what's going to happen is we actually have 2 pathways here. They each involve chemicals, proteins primarily, and some calcium, which we've talked about in the past, that actually will go through what's called a cascade pathway. So one protein will activate another protein, and so on until you get the production of what's called fibrin, which is going to form a mesh. So again, you've got these 2 pathways. We can go down both pathways that will end up forming fibrin, and fibrin is then going to form a mesh over the opening or the cut, and then cells will get stuck in there as they come by. Think about a net like catching fish, the cells being the fish, and then what will happen is we will get a clot, in this case a blood clot, that is going to stop the bleeding, okay, stop the bleeding. Again, 2 pathways. It is a domino effect. The platelets from here will send out signals which will activate proteins that will, one activates with the other, the next one, the next one, the next one, the next one, and both these pathways, both ending in fibrin, which fibrin is going to form that mesh. That mesh, that net, will catch cells. That will form a clot, and then that clot will stop the bleeding, and that is called coagulation. Again, coagulation, forming a blood clot. Agglutination is an immune response. They are different things. Okay, then what will start to happen, and think about the last time you skinned your knee or got a scab. A scab is kind of like that clot. You've got fibrin in there, you've got all the cells in there, and again, they stopped your bleeding. What will happen is, to solidify that process of stopping bleeding, is the clot will kind of retract or tighten in order to again make it more efficient at stopping that bleeding. Now, what's going to happen is the cells under that area that have been damaged are going to start to be replaced. And so when you get a cut on your knee, and here is the fibrin mesh here, and then here are the cells getting stuck, okay, getting stuck in that fibrin mesh. So as it heals, we need that clot to break down. And you can think about it. You get a scab on your knee, what happens? It starts to shrink. It starts to shrink. That's happening because the cells below it are replaced or healed, then what happens is it will send out a signal that will cause the breakdown of that fibrin. So fibrinolysis is the breakdown of that fibrin mesh. So plasminogen, let me just go through these and then I'll show you what's going to happen. So plasminogen is in a clot, but it's inactive until TPA is secreted by the healed cells. So what's going to happen is, as those cells heal, they will secrete TPA. Okay, they will secrete TPA. TPA is then going to cause plasminogen, which is just hanging out in your bloodstream. That TPA is going to cause the plasminogen to be converted into plasmin. So there's no plasmin unless you have TPA. Plasmin will then cause the digestion of the fibrin mesh. So as those cells heal, they send out TPA. That converts plasminogen into plasmin, which digests the fibrin, and you get the breakdown of that clot. This TPA, just so you know, this is what's used for people when they're having heart attacks, in a synthetic form of it. So when someone has a clot that gets stuck in an artery of the heart, they can give them TPA in a much higher dose than the body would ever produce, and that can break down the clot. So we use a synthetic form of what you naturally produce to help people that are having a heart attack and are having a blockage to the arteries of their heart. Okay, so that is the general overview of the process of hemostasis. Real quickly, what hemophilia is. Again, I showed you how coagulation is a cascade effect. So one protein signals another protein, and so on. In hemophilia, what happens is they are missing, because they are proteins and there are genes for those proteins, they have a mutated gene. And so one of those dominoes is missing. They are missing one of those proteins. So as the one before it is trying to activate it, there's nothing there for it to activate. And so what happens is their process of coagulation does not work very efficiently. Remember, I told you there are two pathways. One of their pathways will work, but the other one will not. So a lot of times they're not very efficient at stopping bleeding, especially when it's internal. Because when it's external, first of all, someone notices that they're bleeding and can apply pressure and so on. But if it's internal, and when you get a bruise, that's what that is internal bleeding. So someone with hemophilia, whacks their arm against a table, they start to bleed internally and don't know it. Then what can happen is they can keep continuing to bleed and actually have so much fluid that they can stop blood flow going to certain areas of the body. So one way they help them is they give them the plasma of somebody who does have this protein. So that provides them temporarily with the protein they are missing in order to help them form a blood clot and stop the bleeding. Hemophilia, we talked about CRISPR-Cas9 and genetically changing cells. One of the diseases that this would be really beneficial for, if we could change the gene that makes the protein they are missing, so if we could change the gene to make it a normal gene, so it produced that protein, then they would actually be healed permanently from hemophilia. So hopefully someday we will get to that point. All right, this just shows you severe bruising. This could be just from a simple, a simple bang against a table at the wrong place in the body that causes bleeding, and they can't stop it. Then they will just continue to bleed. Okay. This is a little hippo guy. He's just going to end this video because we all need a little bit of happiness, and he's kind of looks happy and will make you happy. So that is the end of the video on hemostasis. If you have any questions, please let me know.